how to come up with a general model that we can use to model an option that is behaving this way. Yeah, so the model considers a stock or any other asset whose price currently could be SO, so that this is time now, 1, 2. Assuming this is a 2-period model, if the price at the beginning is SO, at the end of first observation, the price could go up so that it becomes SU, or it could drop from SO to SD. Now, in the second day, at the end of day 2, if the price had gone up, it could go up further, or it could this time go down to become this. If the price had gone down, it could go up to become that, or go down further to become that. So that's a binomial tree reflecting price movement of the underlying. Now, our job is to look at the price movement or the value, how the value of the option whose underlying asset has a price behaving this way. So we want a certain value F. This can be FU, FUD, FUU, FUD, FDD. So those are possible outcomes in terms of the option, given that the price is behaving this way. Its value, of course, will be a replica, or it will mimic the price movement for the underlying asset. So we saw how we can use this as a matter of principle to obtain the value through backward. I hope you remember that backward thing, backward induction, until you get the final thing. We did an example. I don't know whether you recall that example, but we can revisit it, since we are not behind the schedule. So we know that there is a relationship between SU, we said it is U times SO, and SD is D times SO. And that in the arbitrage-free environment, we also know that at any given point in time, the expected price of the asset at time t, it is the current price, which is SO exponential RT. That is another way of getting the expected price at time t. You can forecast the underlying price like that. Yeah, that's how you can forecast. But remember, when we are computing the value of the option, we are using the actual. When we are computing the price, we are using the actual. But in estimation, because we are modeling, you can estimate the future price movement, assuming that there will be no arbitrage, and we know arbitrage is making risk-free money That means you make money without investing anything. And we also said that the expected price we can also say it is a probability that the price will go up times the price when it has gone up, which is USO, plus probability of the price going down, which is 1 minus the probability the price goes up, times the value of that price, which is DSO. Yeah, this is also true. It's also another way of getting the expected price. But we know SO is equal to exponential. It's equal to the expected price, which means we can also say SO exponential RT is equal to PUSO plus 1 minus P. Let's just keep that so that times DSO. Yeah, we can have that one there like that. So this one, we have seen SO is appearing on all sides. So this and this can cancel, so that we remain with exponential RT is equal to PU plus 1, if I open this bracket, minus P no. This I cannot open, times D. So maybe to open, I can say PU plus D minus DP. Yeah, that one looks nicer. So we want to find probability P, which is a risk-neutral probability that the price will go up. So that the probability price will go down, it is simply 1 minus P. So we can have PU minus PD or DP plus D. I don't know whether it's making sense. Is it possible I made a mistake? Yeah, so let me hope I've not made a mistake. I've just said exponential RT is equal to, where is PU minus PD plus D. Yeah, so PU minus PD plus D. So I can factorize this P into U minus D plus D. So exponential RT minus D is equal to P U minus D, which means P, which is the probability that the price will go up, is simply exponential RT minus D over U minus D. So that the other probability, the counterpart is going to be 1 minus P, because the two events are mutually exclusive and they are exhaustive. So that is the probability that the price will go up. So that the 1 minus P is equal to 1 minus exponential RT minus D over U minus D. So you can work out that. We can work out the denominator is going to be U minus D, the LCM of 1 and U minus D. So 1 into U minus D is is what? Is U minus D. So U minus D times 1 is U minus D. Then that one is 1. So minus exponential RT minus D. Yeah. So is it minus or plus? It's minus the whole of this. Yeah, minus the whole of that, which is roughly, if you open the bracket, U minus D minus exponential RT plus, if you open that bracket, then divide by U minus D. D negative T and T cancel. So we're gonna have 1 minus P. Let me use the blue. 1 minus P is equal to U minus exponential RT over U minus D. So that is the value which in some quotas we can represent that with Q. The probability in the binomial model, the probability that the price will go down. We can denote that with Q, so that P we have, then Q we have. So this approach I have adopted, we use it to compute the risk neutral probability P. Of course, once you have P, getting the other one minus P is not difficult. So in the notes, I don't know whether I had uploaded this one. There is a write-up on binomial trees that I have. I think if I didn't upload, I'll check. I need to upload this so that we can see how to derive these things. And usually, under risk neutral condition, U can be given by exponential volatility, the root of T or whatever, so that D is the inverse of this. T is the inverse of this, which is negative volatility, the root of T. That means that U is equal to 1 over D. Or D is equal to 1 over U, the other way around. So that is how to, the two parameters, U and D, had already indicated that the relationship is that U is greater than 1 no, we can say that U is greater than 1 is greater than exponential RT is greater than D. Yeah. So U is the greatest. For risk neutral conditions to hold this relationship, the inequality must hold. Otherwise, you can identify some if that inequality does not hold, then arbitrage opportunity might exist. So that is very important. And exponential, of course, of course, how to calculate this, U and D, that relationship was established by somebody called Cox, together with Ross and another fellow called Rapinstein. So this thinking happened in 1979. It appeared in the first publication in 1979. That's when they saw that the relationship between U and D can be established if there is risk neutral condition, so that one is the inverse of the other. But how to calculate it is a matter of volatility. That this element here is volatility. Volatility of the price, of course, volatility of the underlying price, which you can compute using the historical data about the price movements for the underlying. And of course, T, the uppercase T is the time to maturity, how much time is remaining. So usually it is less than a year. No wonder in some books, instead of T, they use delta T, which means a small change in time. So instead of T, you can use delta T, which is a small change in time. So there is no harm representing that with uppercase T. So that is it. I don't know whether we had actually looked at a small example.
Yeah. Excuse me, Malim.
Yes.
When referring to the small change in time, suppose the periods are 2 or 5 or 3, are we supposed to multiply the time period with the rate?
It depends on how time is being measured. We can use delta T because normally options, for instance, they are short-term risk management tools. They do not go beyond a year in practical cases. So you will find that time to maturity is days, but you have to express the same as a fraction of a year. So that if time to maturity is 50 days, then delta T is going to be 50 out of 360. Are you getting? So that you express it as a fraction of a year, because volatility is annual, interest rate is usually annual as well.
So suppose now you have like 2 years.
2 years now, that
When,
is T. You will say T is 2.
okay.
Yeah. But where it is less than a year, like 50 days, so your delta T is going to be 50 out of 365. So you will get a very small value, so that you get the square root of that small value times volatility per year. So where T you replace with delta T, depending on how time is measured. But strictly speaking, options are making sense in the short run. You cannot have an option that goes beyond a year. As you will study the differences between options and forward contracts, one of the key distinctions is that forward contracts can be useful in the long run. They are usually an alternative risk strategy for long-term forward contracts. Yeah, they are very nice in the long term. But short term, what you need is usually the options, specifically the American options, because one can exercise at any time. Somebody is waiting in the waiting room. I think I don't have waiting room. Yeah, I disabled waiting. So whoever is claiming to be in the waiting, maybe he clicked a wrong link. I disabled that function. So I hope it is making sense, the two parameters U and T.
Yes.
And this is very critical because you will find it very prominent in exam questions, how to calculate, how to use binomial tree. Maybe we can revisit and apply this on an example. Although we did an example, but there is no harm doing a refresher.
No, Professor, we didn't do an example. We were to do it in the next class. That's today.
Oh, we didn't do.
Yeah, we did not
No, we
even
didn't.
touch these formulas.
We did not even touch these formulas.
Yes.
But
And you?
it's good we have touched. So I think we can now look at an example. I'm looking at a very good example. Maybe I can use this. What do I do? I can, if I paste it in the chat, can you see it? Let me see whether, you must learn how to utilize technology. Let me see whether I can paste. Are you seeing the question? No. In the chat.
No.
So you check the chat. Oh, I've not sent. I've pasted, but I've not yet pressed send. Now you can see it.
Yes.
Don't
Yes.
worry about the.
Yes, we have seen it.
Don't worry about the derivative game. Derivative game is a software for. Derivative game is a software for valuing options. They're developed by a guy called John Hub. So we are not using it. So the question is, a stock index is currently 810 and has a volatility of 20% and a dividend yield of 2%. This question is bad. Let me see. I didn't want us to go into issues of dividend. Post it first, because dividend has an impact on the price. But even if we can use this to illustrate something, yeah, let's use this example to learn something. A stock index is currently 810 and has a volatility of 20% and a dividend yield of 2%. The risk-free rate is 5%. So this thing is showing, I think this question, don't copy it. It has an element. So that question, we can pose it. I want a simpler one which does not have things we haven't looked at. How come ati kuna watu waiting room? I disabled waiting. So those are people who are not on internet, maybe. That question I had given, just pose it. I want a more reasonable question that does not have dividends. Because if I'm to refer to that diagram, okay, maybe I see. If I can copy it, then it's nice. I can still paste. Using technology, you can see. That is the problem with the online. If we were manual, I could have just, but let me test this technology. But those who have joined now may not see the previous chart. It cannot. Okay. I don't know if I share with you this. We can calculate something as it is. because it's referring to something you don't have. Because we do not have, just refer to the question, which is saying a stock index is currently 810 and has a volatility of 20%, a dividend yield of 20%, 2%. Ignore that, of course, we do not use it. Then, of course, maybe maybe as a preview, the impact of dividend is to reduce the risk-free rate. So that we can now use what we know to calculate a few things. So in this case, you are told that use the output from the river game for valuing a European 6-month call option with a strike price of 800 using a 2-step tree. Now, let me ask you, if maturity is 6 months, maturity is 6 months, and we are using two period. We are using 2 period or two steps. So per step is how many months? Per step is 3 months, isn't it? Which is a quarter. So using general reasoning, delta t, which is less than a year, is 0.25. It's a quarter. That's very important to interpret. If you don't know this one, then you are done. Volatility, you are given it is 20%, so which is 0.2. Volatility is 20%, which is 0.2. So I wanted us to use this to calculate a few things. It's going to be exponential. That's delta, which is volatility, times the square root of 0.25. So U is roughly, using a calculator, is 1.1052. So that's the probability. That is not the probability, it is a factor. Let me wrap it. It's actually a factor. U is the factor, which is a multiplier that tells you how many times the price will go up. So it is 0.1052. That is the multiplier factor by which the price will go up. D is 1 over U, which is roughly 0. D is always less than 1. So if you want to know you are right, it has to be less than 1. So D is that. So what else do we know? So P is maybe what we need first of all is R. So in this R, because it's now R star, because it is subject to dividend, adjusted R, which is risk-free, the nominal risk-free is 0.05, which is 5%. Dividend yield is 2%, so minus 0.02. So that gives you the adjusted R in the presence of dividend. Without dividend, you take risk-free as the nominal value. So adjusted R is going to be 0.03. Yeah. So that is your adjusted R. So that P, which is the probability of the price going up, is exponential R, which is 0.03 times T, which is 0.25 minus D. D is 0.9048 divided by U, which is 1.1052 minus D, which is 0.948. Yeah. So roughly speaking, if you work out carefully with your calculator, you will find that P, which is probability that the price will go up, is 0.5126. Always work with the 4 decimals for accuracy. So this is the probability that the price will go up. Any question? So I was only using this example to demonstrate how to compute the parameters that will be used to calculate the value of the option. So I have, yes.
Does it imply that when we are calculating the value of P, we have to use the change in time for period 1 and not the entire period, which is 0.5?
Yeah, per period, we are using 0.25 because volatility is per year. So we now look at per period. Per period, the applicable unit of time is in this case 0.25. So that it is consistent with the rest of the data, which are measured per year, like volatility is per year, risk-free rate is per year, etc. Unless the data you are given is per period. If it was per period, then our T will be 1. But in this case, expressly, it is 6 months, and we are using a 2-period model, so each period is a quarter a year. That is why we are using a quarter, so that it is a fraction of a year.
But suppose the period was continuous, will we use a half, or?
If it was a 1-period model, we could have used a half. Yes.
Thank you.
If it was 1 period.
Thank you.
Yeah, half, which is half of the year. So that is how to calculate these parameters. So far, I will find a good example, which I can even in that term paper that you are looking at, I think we can find. Maybe I can put this question.
Just as a simple question, the last question, Mwalimu.
Yes.
How did we get 0.02?
0.02.
In the adjustment of the rate.
0.02 is the dividend yield. We were adjusting the risk-free rate. If there is dividend being paid, it reduces the risk-free rate. So we subtract. The dividend yield was 2%. The nominal risk-free rate was 5%.
Okay, thank you.
Yeah. So let me put in the chat another question we try. this one might make sense. You are told that a stock is this, it's known that to either be or, yeah, this is another good example. Let me put in the chat. If somebody joins later, hataona is one. I have a way to paste it there, yeah. You can also copy it in your own way somewhere. You can select and copy. So we are told a stock price is currently 50. It is known that at the end of 6 months, it will be either 45 or 55. It will go down to 45 or up to 50. The risk-free rate is 10% per annum with the continuous compounding. What is the value of a 6-month European put option with a strike of 50? So, someone to interpret, this is high-level question. It is simple but high level. Someone to interpret for us. How many periods are we doing? It's a 1 period model, isn't it? Just 1 period. Yeah. And what else can you infer? You can infer that the price can go up to 55 or down to 45. So what is U? Can you compute U? If the price drops to 45, what is the rate of? You know, this is now common sense. You don't use the formula because of lack of the other data, but you have been given a hint on what to do. So this one, let us do it. I hope you have seen the question. It's in our chat. So this one, we are being asked, what is the value of a 6-month European put option with a strike of 50? Strike of 50 is the exercise price of 50. So let us bring out the relevant data from this. So from here, we can say that D is 45 out of 50. So this one is roughly what?
$0.9.
So 45 divided by 50 is 0.9. That is T. Then U is 55 out of 50. Which is 1.1. Is it the same as 0? Is it the same as 1 divided by 0.9? Somehow, it could still make sense. Yeah, the relationship is not very bad. Risk-free assumption can still apply. Then risk-free is 10%, so it is 0.1. What is the value of European put option with strike? So exercise price is 50. Current price is 50 as well. Yeah, current price is 50, exercise price is 50. So this is a 1 period model. So we can say the current price is 50 and the price could go up to 55 or down to 45. Yeah, that is what we are being told. Maybe the other thing we needed to calculate is P, probability of the price going up. So P, we said, is exponential this is 6 months, so it's going to be exponential R times T, which is 0.1 times T, which is a half, minus D, which is 0.9, divided by 1.1 minus 0.9. So someone who has a good calculator to get us the value of P, which means the probability of the price going up. What is P? I don't have a scientific calculator. Somebody with one to calculate for us. Has somebody obtained? Yeah, I hope you are correct. 0.7564. Yeah, let us use that, which means 1 minus P is 0.2436. Yeah, let's hope it is correct. You know, we are working as a team, so that's the probability that the price will drop, and the other one is probability that the price will remain. So value of the option, you know, we are calculating something there to use it to get something there. So this is our F, this is our FU, this is our FD. Now FU is the present value of the expectation of the option payoff, which is whenever you are talking about present value, you say negative exponential delta t, because this is less than a year when you are discounting. So F, let me just write this, probability of the price going up times the value when the price has gone up, plus probability the price will go down times the value when the price has gone down. Yeah, just the present value. You will see when we are now implementing this model, which is now the binomial option pricing model, you see that we are just getting present value of the expected value. For one period model, it's quite simple. Maybe we shall try a more advanced example with 3 or more payments or observation periods. So in this case, let me move, if you have taken a snapshot of this, let me move to the next slide. I will just rewrite it. But let's finish with this slide before I go to the next slide. So let me put it in red. The value in this box here when the price has gone up is the payoff. And we know that payoff, if it is a put, this is a put option. Put option payoff is exercise price minus for a put. You can recall that for a put, it is the value of the put is either 0 maximum of either 0 or x minus st. Yeah. Yeah, it's either 0. In this case, our x is 50, our st is 55. So 50 minus 55 is -5. So we take 0, which is the better of the two. We take 0. Then 50 minus 45 or 0, we take 5, which is 50 minus that. So these are the terminal values, the payoff. Now to get here, we discount that. So we have 0 and 5. So let me now go to the formula and implement. I have said f is the present value, which is exponential r delta t times the value of f when the price has gone up. Let me first of all begin with probability of fu plus 1 minus p times fd. In this example, we are going to say exponential negative. What is r? R remains 0.1 times 0.5. The probability that the price goes up is 0.7564 times 0. The value when the price has gone up, plus the other one was 0. You said 2
436.
436 times 5. Yeah. So now, of course, 0 times a number, you get 0. So 0.2436 times 5 times exponential. This is like exponential 0.0 negative 0.05. Yeah. So it's like exponential negative 0.005. Times whatever you get.
How's your meeting? Your bosses. You're happy?
Yes. So, that one is.
So maybe
So exponential, I think it is like that. So 1.218 times exponential negative, that somebody with a scientific calculator to get for us that answer. Somebody with a scientific calculator to get for us that. So you are getting 1.1586. Yeah. So that is actually the value of the option. Yeah. So that is our value of the option. So with this, you can meditate and see how to apply the model to compute the price of the. So I think we can, let me check the questions that, no, I don't think, I've not uploaded any past papers. Maybe I should upload 1 or 2 past papers for you to look at, the expectation. So I can look at another question. Maybe I can copy this. There is a question here. I can copy up to there. We can try this one. So pick keen on what we are doing. So are you able to see that one?
Yes.
Yeah, go through it, then we do. Consider European call option on an undividend paying stock where the stock price is 40. The strike price is 40. Risk-free rate is 4. And volatility is 30 per annum. And the time to maturity is 6 months. Calculate U, D, and P for a 2-step tree, which means there are 2 observations. Then value the option using a 2-step tree. Yeah, this is a very nice one. I think this one we can do. We have done 1 tree or 1 step. This one has 2 steps. So we can also do this one. Let me open. So for this one, we know that, let me write in blue. For this one, the good thing it's non-dividend paying, so risk-free is not going to be adjusted. We know that the current price is 40. Exercise price is 40. Another thing we know is that R is 4%, which is 0.04. volatility is 30%, which is 0.3. So we know a lot we have been given. So using this, we are asked to calculate U. U is exponential square root of delta t, which in this case is exponential 0.3 times the square root of 0.25. I think delta t here, we didn't give it 0.25. Yeah, delta t is 0.25 because maturity is 6 months, which means if there are 2 observations, then per observation is a quarter, 3 months, which is a quarter. So that is our U. Someone with a good calculator to give us the value of U. Exponential 0.3 times the root of 0.25. Somebody with a scientific calculator, please. Post the answer, please. What is U? You are saying 0.8. You are getting different answers. You cannot be less than 1.
1.1618.
1.161.
Let's see the consistency. So 1.16. Somebody saying 1.6. Or you have edited. Protich, is that correct? Yeah. Now you have corrected. So it is 1.1618, isn't it? That looks more genuine. Yeah. Remember, you cannot be less than 1. Already, that rule is there. Then D is simply 1 over U, which is what? It's 608. 8607. Are you getting like that?
Yes.
It's just the inverse of what we have.
Yes.
Yeah, something like that. And it's always nice to work with the 4 decimals if you want to be accurate, because if you truncate to 1 decimal, you will find at one point you have a value like this. So to 1 decimal, will you say you got 0? Which you will be wrong. So it's good to work with the 4 decimals or even more. This is nice. So we have answered the question in part. We have answered U, D, P. P, we said it's exponential negative delta t in this case, minus d over U minus d. So this one is exponential 0 times 0.4 times 0.25 minus d. D is 0.8607 divided by 1.1618 minus 0.8607. So somebody very, very competent in using a calculator to give us an answer. If you want to be careful, you work the numerator first, then you work the denominator, then you get the answer. Although some people have a good calculator where you can write the equation the way it is and get the answer. Kimosopu umepata 2960, 04960. I hope it is correct. Other people to verify? We need 3 or 4 witnesses. So that if the answer is wrong, then we go by the majority, even if it's wrong. Yeah, so that is probability. Hey, somebody else is getting 4962. Who is now wrong? Anybody else who is getting 4962? Yeah, 4960. Yeah, I think. And by the way, are you people all in Nairobi or others are in Kisumu? Because if you are all in Nairobi, we could have arranged a face-to-face class in November, 1 or 2, at least 1 class.
Yes, we can have. If we arrange it well, I can travel to Nairobi. I'm in Kisumu.
Yeah,
Professor.
I think it's nice if we can. I'll ask the faculty manager.
Yeah.
To find a way to communicate to all of you so that we have one face-to-face, so that we do a recap to avoid the hitches we have based on technology. Unless somebody, we cannot have a face-to-face if somebody says it's impossible to come. One person is enough to call off the whole thing.
It might be a challenge, Mwalimu, because of work schedules.
Yeah, if it's not possible, we can't meet at the expense of only one person is enough. A quorum is 1. So if one person is not making it, then we shall continue being virtual. It will be violation of our rules if one person is not able to come.
Dr. What if it is made on over the weekend? Can that work?
That guy who is saying it's impossible, huyo ndiye atafanya isifanyike. He could be an SDA.
But I think again, we can actually choose a day, one of the days of the weekend, because actually time will not be there. It is just to create time so that we can have the physical class over the weekend. I think that would be better.
We shall chat in the group and see when we propose who can't and what can we do for that particular guy. Because it's not possible to have 100%.
It's okay.
Yeah, so we'll arrange somewhere within November. We shall discuss in the group so that we have at least one.
How will the people in course sit for any term exam in Nairobi? Ama?
Everybody will come and do the exam in Nairobi. But those in Kisumu, then we shall dispatch the exam there. Anyway, let us see how it turns out.
Daktari.
Yes.
Even in the virtual, you don't get 100%.
Yeah. There are guys with various reasons.
Yes, so it will be prudent for us to arrange 2 or 3. Two will be okay.
We shall start with one face-to-face. Then we see if it's necessary to organize another. So let's first of all make a trial for one. I'll talk with the faculty manager so that it's official. Yeah, so that when you travel, it's official that we have arranged. John Ogalo, you have raised your hand.
Oh, sorry. I think I had spoken earlier. Let me just lower my hand.
Okay, sir. Yeah, so that is it. So that is my own initiative. It's usually not the case. But you see, the purpose of these things is not to finish the syllabus, but to engage effectively. So that question is done. I'm looking for another nice question.
What about part B, Mwalimu?
Part B. Yeah, part B. So I think once we do part B, we shall have met the objective for the day. The objective today was ability to use binomial tree to value a call or a put option using the binomial option pricing model. So if we do this, we shall have killed the objective of today. So value the option using a two-step tree. And this is a European call. The other one was a put. It's nice now we are doing a call. Before we go to the next page, no, let me just save this. Yeah, so it's good to draw it on a tree. So the current price is 40. No, let me write it. The current price is 40. So the price could go up or down. And we said U is what? Someone to recall U is 1 point.
$1.1618.
And the other one was 0 point.
8606.
86. No. It was what?
5.
Yeah? 0 point.
You
8,
was
8607.
8607.
8607. Yeah. So now this is how you do it. 40 times 1.1618. What do you get? Multiply 40 with U. What do you get?
6.472.
4647.
46 point. Now for price you can work with the 2 decimals. 46.47. So this one you can work with the 4 decimals because it's money. No. What have I written? And the other one is
4.43.
34.43.
34. Yeah. So those are that's the price. Then the price will go up further or down. Up or down further. So if 46.47 goes up further, you just multiply with the same factor. I'm getting here 53.99. 53.99. Then the other one, if it goes down, you get this one, 39 point. Oh, it comes to 40. Are you also getting 40 here to 2 decimals? Eh?
Yes.
Yes.
So it is the same 46.47 coming down should give you the same value as 34.43 going up. I hope you get the same because we are dealing with arbitrage free. This one we are getting 29.63. Yeah. So see, it is a 2 period, 2 step. So this is 1, 2. This is 0. Yeah. So this is 2-step model. So we want to use this now to get a value there, to get a value there, then to get another value there, then another value there, another value there. The one we are looking for at the onset is that one. So this is our F, this is our FU, this is our FD, this is our FUU, this is our FUD, this is our FDD. Yeah. So we insert some values inside there. So the terminal values are easy to find. You are simply calculating the payoff. And we know that the exercise price is 40. For our call option, we know that value of our call is 0 or the maximum of 0 or ST minus X. Yeah, you get the maximum of either 0 or ST minus X. In this case, ST is 59.99 and X is 40. So we simply say 53.99 minus 40. So you are getting 13.99. I hope you see it. Then here, the price is 40. 40 minus 40 is 0. And here is 0. Yeah. So 0, whatever you get here, instead of wasting time, whatever you multiply, you will still get 0. 0 times a number plus whatever, it's still 0. Yeah. So we are looking for here and here. Then we finish. So FU is going to be exponential negative. What was R? R is 4%, which is 0.04 times 2 step. So this is 0.25. So times probability of the price going up, mulipata ngapi? 0. Probability of the price going up.
0.4960.
0.4?
4960.
Okay. 4960 times 13.99 plus this other one, probably minus 1. So if P was 0.49, 1 minus P was
0.5040.
0.5040. 40, yeah, something like that. So it means that it is 0.540 times 0. Of course, we are just writing to show if there was another value